Alright, in this video we're going to look at this following problem. A USA Today poll asked a random sample of 1,012 US adults what they do with the milk in their cereal bowl after they have eaten. Let P hat be the proportion of people in the sample who drink the cereal milk. A spokesman for the dairy industry claims that 70% of all US adults drink the cereal milk. Suppose this claim is true. So first step, we want to calculate the mean and the standard deviation of the sampling distribution of P hat. Alright, so whenever we're doing the sampling distribution, that's the distribution of all the values, which we believe is going to be normal. We'll check that here in a minute. And so we're looking for the mean, which is the center of our distribution because it's a normal curve, and the mean for the sampling distribution equals our proportion, our population proportion, which is 70%. So the mean of our sampling proportion, so we're going to represent it as mu of P hat, equals P, which is 0.70, 70%. Now our standard deviation, that's how wide this distribution is. So the standard deviation of P hat equals the square root of P times 1 minus P divided by N, where N is our sample size. So our P is 0.7, so we'll go ahead and plug that in. 0.7 times 1 minus 0.7 divided by 1,012. So we'll go ahead and punch that into the calculator. So we're going to do the square root, do alpha y equals, so we can make it a fraction. So 0.7 times 1 minus 0.7 divided by 1,012 gives us our standard deviation, which is 0.014. That's our standard deviation of our P hat, of our sampling distribution. Now for B, we want to justify that the sampling distribution is approximately normal. Again, we assume it is at the beginning of this problem. Now we're going to check to see if it actually is. And we can use the large counts condition to check that. And the large counts condition is that N times P, where N is our sample size and P is our population proportion, that has to be greater than or equal to 10. And N times 1 minus P also has to be greater than or equal to 10. So we'll check the first step. Now our N is 1,012. So we can do 1,012 multiplied by 0.7. We want that number to be greater than or equal to 10. So we'll go to our calculator. So 1012 times 0.7 gives us 708. So 708 is greater than or equal to 10, so we satisfy the condition there. Now let's check this other side. So N is still 1,012, and we do 1 minus 0.7. We need that to be greater than or equal to 10. So going into our calculator, so 1,012 times, open parentheses, 1 minus 0.7, that gives us 303. So 303 is greater than or equal to 10, so we're good there. So it is approximately normal because both of these conditions are satisfied. Now because we've satisfied the normal condition, we can find the probability that at most 67% of the people on the sample drink their cereal milk. So we want to find the probability that X is less than or equal to 0.67. Now, because it's approximately normal, we're going to use our normal CDF. So we go second bars to get to the distribution. Go down to option 2, normal CDF. Now, in this case, our lower is going to be a big negative number because we want everything less than 0.67. So we put an upper 0.67. Our mu, we found that in the first part, that's 0.7 because it's our sampling, it's our P, our population proportion, and our standard deviation is 0.014. Alright, so we'll go ahead and calculate that out, and we find that our probability is 0.016. So 1.6% of the time, 67% or less of the people that we survey will drink the milk.